So we are still on AC circuit. So if you've been following with my series on AC, I think I've done 3 videos. This is the 3rd one, and for this one I'll be very quick because I'll be showing you my calculations, because the other one were like 20 minutes because I was also showing how to punch the calculator. So by now, if you've been following, I think you know how to work with the calculator in complex form. So I won't be showing that anymore. So my focus will be on solving the problem and how the method around it, not really the numbers and whatnot. So the first question that we're looking, let me just read the statement. Okay, the circuit below, okay, and then we're given this current going in, we're given this, it's also said to be LMS, and then we're given loads, 3 loads and the resistor, and then we told the current is also an RMS. Calculate the apparent power. So for me, apparent power, the way I like to think about it, so now I'm back on my normal pen, so I think it should be quicker. Apparent power is this one. This is measured in VA. This one is going to be VAR, and this one is going to be watts. So apparent power, it's more of like the hypotenuse. Yeah, so this one is going to have the apparent power is going to have the real and the complex part. So that's how I think about it and calculate it. So of the load, is going to be, adding everything here, it's going to be 1. I see 1 there, kilo, and I see another J. For a capacitance, it's going to be a minus, so it's going to be plus 1 and plus minus a 5, and then that an inductive on 2, it's going to be plus 5 real, that's J, and the other one is going to be inductive, right? It's going to be a plus 10 J. So your question would be, why now you did this minus for a capacitor? Remember, a capacitor in impedance, it's like this, 1 all over I think JWC. Remember, if J is in the bottom, it can bring up, if you bring it up here, it's going to be negative. So that's why I'm negating my power for an inductive, or I mean a capacitive load 3. So if I do my math here, this is going to be real, this is going to be real, and I think this is going to be real. To confirm, this is going to be real, this is going to be real, this is going to be real, and if I add that, I get 7 real. And for complex, I'm going to use a blue pen. There's going to be complex, there's going to be complex, there's going to be complex, or unreal, whatever word you want to use, but this is going to be negative because it's capacitive, whatever I can say. Then it's going to be 1 minus 5 plus 10. Remember, this thing is in kilo VA, we said here, kilo VA. So if I do very well, it's going to be 7 plus, here, oh, my math is so bad, okay, so that's going to be a 5, then a 6. Remember, this is complex, kVA. So we have solved the part of apparent power. That was 2.1. So let's try to solve 2.2. Calculate the angle of apparent power. I think it's that one. So we know this and that, so we can use tan. Then we're going to put the complex part is 6 all over the real part, I think it's 7. Then I punch this in my, okay, depending how your teacher wants it. If I put mine, I'm using degrees, it's going to be 40.60, degrees, I don't need to be more accurate. Cool. So the next question, what is an active power of R? Okay, cool, that's nice to know that power exactly should be Vi, and we know V was given there. V was given to be 500, that was 2.3. I'm trying to be quick, and current was given to be 20. They are all in RMS, so exactly this is the conjugate, so it really doesn't matter because there's no complex and it's all only real, so it's going to be 500 multiplied by, I should be able to do this thing by head, but I'm just lazy. I think I'm getting 10,000 VA, yeah, so you can just make it 10 kilo of VA because most of our things are like that, and kilos. Then what is the question? Active for power for R, I mean. So we now know that squared should give me the real part squared, of which the real part is going to be 7 plus the power of the resistor all squared plus the power the complex power, which is going to be 6 all squared. Then my goal is what is finding this guy here. So on me trying to achieve my goal, I'm just going to plug in this here. It's going to be 10 squared minus 6 squared, then take this root, make it a root here. It's going to be 7 plus power at R. Then I'll have to be negative, then equals and go here. That was very nice. And then from then I think I can solve. I can just put my calculator. P power at R is going to be, and then if I compute very well, I get the answer of 1. It is real, so it should be in watts. Remember, everything is in kilos. So after we have solved this part, what is the value of R? I think we can say power is equals to VI, but we know V is going to equals to IR. If we plug it back here, we'll have I squared and R P, sub this here. Then our that is power for R. Trying to get, what are you trying to get? Trying to get this guy. Okay, cool. So current was given to be 20, if I'm not mistaken, all squared. Power for R, now we know it's going to be 1. Let me just 1000 because it's kilo and we're trying to find R. Then if we do the correct math, now it's going to be 1000 divided by 20 all squared. The correct answer is going to be 2.5 ohms. So we have solved it. Let's look at the next question. Solve that one. Now what is the power factor? Remember, power factor is going to be cos theta. But now what is our theta? We know our theta is going to be cos. We already got theta there. It was tan arctan of I don't know what it was. Where did you get it? 6. The real part was, which one was real? It was complex over real. So complex is 6 all over, I think. Now it's going to be 8 because plus 1 of the real part is going to be 8 here. Then I think I need double brackets here. Then I put my calculator, and then if I on my calculator I'm getting something like, let me check, 4 over 5, of which is 0.8. remember this is a ratio, so no dimensions, right? So any question missing? We already solved this one, so then we are done. So I think it's not an easy thing not a hard thing to do. Please check other videos. I think I have 3 videos on this topic. Please check them out. They're also going to be helpful. Good luck. Don't forget to comment if you spotted a mistake or if there's something you want to ask, or don't forget to share and subscribe. Thank you.